Okay, welcome to the video for lesson 1-6, Compound Inequalities, part 2. So in example 1, just to review real quick, we have an introduction to compound inequalities. Something that I wanted you to notice, and we're going to see that in example 2 and 3, the explanation, is that the solutions either had or in it, and this other one had and. And we're going to see, does it matter which one it has? And if so, is there a pattern that we see of what the graph is going to look like if it has or versus what the graph will look like if it has and? So let's go to example number 2, solving compound inequalities involving or. So for this first example of part 2, it says solve the compound inequality 5x minus 7 is less than 13, or the solution is negative 4x plus 3 is greater than 11. So we're going to do each piece at a time. We're going to take this first one. We have 5x minus 7 is less than 13. I'm going to draw just my vertical line here. So I want to get the variable or the term with the variable x by itself. So then I'm going to move the 7 by doing the opposite or the inverse, which means I have to add 7 to both sides. These cancel out, so I'm left with 5x on the left. And then 13 plus 7, we get 20. Our next step to isolate the variable x would be to divide by our coefficient 5 to get the x by itself. Because we're dividing by a positive number, the inequality symbol stays the same. 20 divided by 5 is 4. So now let's sketch what that would look like as a number line. So I'm going to go ahead and add 4 to my number line. I'm going to go ahead and put a value, the one that comes after and the one that comes before. So the less than symbol tells me it's going to be an open circle at 4. Less than is everything to the left. So 3 is less than 4. Now we're going to do the second part of the inequality, or the solution could be negative 4x plus 3 is greater than 11. Again, we want the term with the variable x in it to be isolated. So the inverse of adding 3 would be to subtract 3. And whatever we do to one side of the inequality, we have to do to the other to keep it balanced. So therefore, negative 4x is going to be greater than 8. 11 minus 3 is 8. And now we have to divide by our coefficient of negative 4. To get the variable x by itself. Because we divide by a negative, we're going to reverse the inequality symbol from greater than to less than. A positive 8 divided by a negative 4 is negative 2. So we have x is less than negative 2. If we graph that on a number line, I'm going to go ahead and put negative 2 here. This will be negative 1. Over here would be negative 3. I'm going to have an open circle. And since x is less than negative 2, it's going to be everything to the left of negative 2 would be less than. Now, you might notice here's like, they're both pointing to the left. How would I represent that as a compound inequality on the same number line? So your solution has to be true for both inequalities. It has to be true for both. And I'm noticing that since this one's negative 2, negative 2 is already to the left of the number line because this would be 2, 1, 0, negative 1, negative 2 if we continue the number line. And negative 2 is already to the left of 4. So we would just say negative 4 here, we put an open circle, and it would be everything to the left. So in this case, one of the solutions is already included as part of the set of the other solution. So we will just say that the solution is x is less than 4, which is the set of all real numbers that are less than 4. Okay, now I'm going to go ahead and pause it here. I want you to give it a try with the tried example 2. You're going to be solving the compound inequality. Go ahead and use your example 2 to help you with this one. And then you will be able to check your solution. Make sure you give it a try. Compare with your neighbor and see how you're doing.